Hello, friends and colleagues. My name is Joshua. I want to welcome you to an easy to understand tutorial on the use of R for causality and cointegration analysis. We need just 3 packages to do that. One is lmtest for the granger test, VAS to determine the optimal lag length, URCA for the unit root and cointegration analysis. And for our illustration, we want to make use of a data set called ChickEgg in lmtest. So let us load the packages as well as the data. Library lmtest, library VAS, library URCMs, data ChickEgg. To check the structure of the data set, we use str. So it's a time series of 54 years from 1930 to 1983. It's made up of 2 variables. We have chicken and egg. For the granger causality test, the first thing we want to do is to determine our optimal lag length. Because we want to know which comes first, egg or chicken. Or in another word, which one predicts what? Is egg predicted by chicken or the other way around? So to determine our optimal lag length, we use VAS select function from VAS package. Run it. If you look at the various selection criteria, AIC, HQ, SC, FPE, luckily all of them are 2, 2, 2, 2. So we are going to use the lag order 2 in our granger test. So to perform it, we first try to check whether chicken granger cause egg. So we have granger test egg, function of chicken, order already determined to be 2. Then our data set is chick egg. And then we repeat it again, now trying to look at whether egg granger cause chicken. So let's run the 2 and check our results. So if you look at the first one, you can see that the F statistics is not significant. So in that wise, we conclude that chicken does not granger cause egg. But if you look at the second equation, let's check the F. Yeah, this is the F, and it's significant. So we can conclude here that egg actually granger cause chicken. Straightforward, super simple. Now we now know the direction of causality. It's unidirectional. So let's move to our cointegration analysis. We are using a URCA package. We've already loaded the package. Now it's advisable that we convert our ChickEgg data to data frame. So to do that, we just say ChickEgg as.data.frame ChickEgg. So let's run this. And we need to perform the unit root test. Here we want to use augmented Equifuller. First at levels, that's why I say egg L means we want to perform the unit root test on egg at levels. We do that also for chicken. Then for first difference, we have egg, I call it egg D. Just the difference between unit root at levels and difference is what is this function, diff. Every other thing remains the same. So we do that for chicken. That's what I call chick D. So let's run everything and try to interpret the results. So let's look at our results. Egg L, yeah. So if you look at unit root tests for egg at levels, you can see that the statistics is minus 1.63. And if you look at the critical value, it shows that it is not significant. So, and therefore we conclude that egg is non-stationary at levels. So we check the case for first difference. So for first difference, you can see the value is minus 4.33, and compared with this, now we conclude that after first differencing, then we conclude that it is stationary. So you do that also for chicken. So at levels also, you can see that it's minus 0.1998, insignificant. Then after first differencing, okay, that result did not come out, so let's come here. So after first difference is minus 4.38, so it's stationary after first difference. So we now discover that both egg and chicken are integrated of order 1. So and since we achieve that, then we can actually proceed to test for co-integration. So to do that, we regress chicken against egg. Since we already know the direction of causality, so we say model LM, this is like running our OLS actually, which is the linear model. LM chicken as a function of egg. Our data is ChickEgg. Then let's get the summary. So this is our result here. And you can see even the t-value is minus 4.43, and the probability of the t-value is actually very, very, very high. It is almost 0.15. So we may even conclude that the relationship between egg and chicken is not significant. Then we can proceed to the final stage, is actually looking at where we conclude there is no relationship actually in the long run. But you can still proceed and check for the unit root of the residual. At least to be convinced that co-integration does not exist between egg and chicken based on the data we have concluded. So to do that, and that's the last thing we do, that's residual. We want to look at the ADF. So we have URL.df, residual model, so on and so forth. So let's run it. So, and if you compare, this is minus 1.83 and this minus 2.6. So this confirm that co-integration does not exist, even though both are stationary after first difference. So this is the procedure. Super simple and straightforward to do. Thank you for listening. And maybe in case you need the code in text file, you can contact me and I will send it to you. Thank you for listening.